All right. Let's see. Nadia, can you read us the essential question, please? Perfect. And then Henry, can you read us the I can statement?
I can find the absolute extrema of a function using the candidates test.
Perfect. Okay. So we are going to use something called the candidates test. That's what they call it. It's literally a table. Okay, that's all the candidates test is. So we're going to use that to find absolute extrema. And we're going to kind of be able to see here in a minute different ways that they ask us this question. It all means the same thing. Okay, so I'm going to give you about 2 minutes. I want you to take and read through this green table. Okay, so everybody read through that table on your own real quick. Take 2 minutes and do it. Okay, we're not going to reread the table together. You've gotten a chance to read it. We're going to summarize the table in the left-hand column. Okay, so kind of put it in English if you didn't understand what it said. Okay, so out in the left-hand column, to find the absolute extrema on a closed interval analytically. Remember, analytically just means using algebra to do it. Okay, so find the critical numbers. And you hopefully know what critical numbers are at this point. That's when the derivative equals 0 or does not exist. So that was what their number 1 was, right? Find the critical numbers. Then we're going to plug the critical numbers and the endpoints into the original equation. That's what 2 and 3 say. So plug the critical numbers and the endpoints into the original equation. And it's important that you're plugging into the original, not in the derivative. So, because when we do locals, right, when we do our sign charts, we use we use the derivative. We do not use the derivative for this. We use the original equation. Okay. All right. The largest answer is the absolute max. The smallest answer is the absolute min. Okay. We're going to edit this last part a little bit. I don't like what it says. So always justify your answer with, and you can cross that out. College Board has come out and said that the table is a valid justification. So you don't have to write out like all the becauses and that, like we did with the locals, okay, or the the relatives, okay. You just have to write. You justify your answer with the table and conclusion sentence. Did I spell that right? I'm not sure. Conclusion sentence. And the conclusion sentence is right up here. Okay, so we're gonna so you're gonna use that sentence frame that's there at the end. Okay. So at the end of our problem, okay, you're always going to make a statement about the absolute maximum and where it's located, okay? Sometimes they just ask us for the absolute maximum, meaning they just want the y value. Sometimes they ask us just at what x value is the absolute maximum. They just want the x value. It does not hurt to write both, okay? So as long as you have it phrased correctly, they will give you credit, okay? So the absolute maximum is or the absolute minimum is. What you put in here is the y value. So y value always goes in that first blank. X value goes in the second blank. Okay, take a minute and read that bubble to yourself. Okay, you learned, you probably didn't learn it last year because I think I skipped over the lesson last year, but hopefully you figured out by now that the word absolute and the word global are interchangeable, okay? It's trended more towards absolute, but that doesn't mean they can't bring the word global back for us on the actual AP test, okay? So they're interchangeable. They can also just drop that word absolute and that word global and just say, find the maximum or what is the maximum. When they say that, they're talking absolute, okay? If it's a relative, they will always say relative, okay? So absolute is either nothing or the word absolute, okay? Relative is always relative max, relative min, okay? All right, so we're going to actually find this. So we're going to follow those steps that we just wrote out. So let's try example 1 here. So we're going to find the absolute minimum for f of x equals x squared minus 4x plus 3 on the interval from -1 to 4. So the very first thing I need to do is I need to find critical numbers. So to remember to find critical numbers, we're going to take the derivative and set it equal to 0. So f prime of x equals, okay, let's see what we remember. What's the derivative of x squared? Good. Okay, what's the derivative of -4x? -4 and the derivative of 3? Awesome. We didn't forget how to take a basic derivative. Okay, we're going to set that equal to 0 to get our critical numbers. Okay, so I've got 2x equals 4. So what's x equal? What's our critical number? 2. Perfect. Okay, so again, a little bit different than what you did last week. So now what we're going to do is we're literally going to put that in like a T-chart kind of table, and we're going to solve for our endpoints and our critical number into this original equation. Okay, so this is how I set that up. I draw myself a T-chart. Remember, I am picking these x values. They are not assigned. I have to pick them. But we have a standard method on how to pick them. We use the endpoints, so -1 and 4. And we use any critical numbers that we get. So I'm going to use 2. And then we're going to evaluate f of x. Now notice I left a lot of space there on the right side because I like to kind of just plug my work into the table. Okay, if it helps you to do that, great. If not, all you are required to do is have the x and the y value. Okay, if you're plugging it in your head. Okay, so I'm going to plug -1 into this f of x. So -1 squared minus 4 times -1 plus 3. All right, what's -1 squared? 1. -4 times -1. 4, good. All right, 1 plus 4 plus 3, 8. Now, last week we didn't really care what the number was, right? We mostly cared about the sign of the number. Well, we actually need the value this time, okay? So we need to make sure you're calculating that accurately. All right, we're going to plug in the 2 now. So we've got 2 squared minus 4 times 2 plus 3. All right, what's 2 squared? What is -4 times 2? Good. All right, so 4 times -8 plus 3. Sorry, 4 minus 8 plus 3. I said times. -1. Everybody okay with that? Okay. Now we're going to plug the 4 in. So 4 squared minus 4 times 4 plus 3. What's 4 squared? 16. 4 times 4. Good. So 16 minus 16 plus 3. Perfect. Okay, we are going to, I'm going to give you a minute because I still see people writing. So take a minute, catch up. Okay, what's the smallest value we got? -1 was our smallest, right? At this x value. Okay, so let's write our concluding sentence here. All right, so the absolute minimum is, and this is where you put your y value, -1, at x equals 2. It's pretty cut and dry, okay? Because you do the same thing for every problem. That's why when we see these, we can it's a pain because we've got to go through all that calculation, right? But we know exactly what to do when we see this type of problem. And it's usually there's a free response, or one part of a free response question that's this. So it makes that some nice, easy points for us to be able to get. Okay. All right. Let's see. Let's do the next one here. We're just going to keep going. Okay. Because we have some other picky little things that sometimes pop up here. So we need to deal with those. All right. So the next one says find the global maximum for h of x equals x squared over x plus 3 on -2 to 1. All right, so same thing. We see the word global maximum. We know we got to do a candidates test. The first thing I need to do are get critical numbers. How do I get critical numbers? Take the derivative and do what with it? Set it to 0. Okay, so that's good. We know we've got to take the derivative and set it equal to 0. It's a great time to review something, though, isn't it? All right, so what rule do I need to take the derivative of this thing? The quotient rule never goes away, does it? So it's a good time to review it. Okay. You never know where they're going to stick that in. Wait till you see what you can do with free response questions, because it's amazing how they put it together, and they put it together different every single year and still get the same thing out of you. All right. What's the derivative of x squared? 2x, good. And then we're going to keep the green the way it is. We put add or subtract in between. Good. Keep the red the way it is. Take the derivative of the green. What's the derivative of x plus 3? Good, and we have x plus 3 squared. All right. Now, normally on a quotient rule, we would just say, just leave it, but we have to be able to solve for, we have to set it equal to 0, so I should probably just simplify more of it because I'm going to need to be able to solve this. So we're going to distribute the 2 in, so 2x squared plus 6x minus x squared all over x plus 3 squared. Okay, I could combine a little bit more. So what's 2x squared minus x squared? Yeah, x squared plus 6x over x plus 3 squared. Okay, then we're going to set that equal to 0. Okay. All right, so I need to get the denominator over to the other side. Remember, I take this denominator over to the other side by multiplying it by it. So 0 times this denominator is what? 0. So basically, you're setting your numerator equal to 0. Okay. What did I do wrong? Something's not right. I wrote something down. Oh. I did the problem wrong last year. That's nice. Good job, Mrs. Ballard. Okay. Good news is I didn't record video on it last year. So, okay, let's, because the 2 is correct in the front. Yep, I didn't distribute it. All right, I'm going to go ahead and factor out greatest common factor of x. So I've got x plus 6 equals 0. What do I need to do now? Yep, we got to do zero product property. So x equals 0 and x plus 6 equals 0. So we know one of our candidates is 0. X equals negative 6 is another one. However, I want you to look at your interval. I'm going to zoom out just so you can see it all on one screen. Look at the interval and look at this. Is that 6, negative 6 in the interval we're looking at? No. So do I get to use that value in my table? No. In fact, that's good, right? Because the less we have to put in that table, the better. Okay? The less work for us. So if we can eliminate, great. So we know that this one isn't part of it. I'm just going to kind of put a line through it. So I just am telling myself I'm not going to use that. Now, there's another place where we can get critical numbers from. We can also set the denominator of the derivative equal to 0. Because remember, it told us that we get critical numbers when we're equal to 0 or we do not exist. Remember, we do not exist if our denominator is equal to 0. So I also have to take this denominator. I'm going to do this. I'm going to take this denominator and set it equal to 0 as well. So x plus 3 squared equals 0. All right, I have to undo how do I undo the square? Take the square root, technically plus minus, but it's a 0. So x equals negative 3. All right, is negative 3 inside our interval? No. Had that interval been negative 4 to 1, though, we would have had to put the negative 3 in. Okay, so we got lucky, and we don't need this one either. So we're just going to do the candidates test with 0, negative 2, and 1. Okay, so put my candidates test to the right here. Okay. All right, so we only have to test 3 numbers. So we've got x and or h of x this time. And we're going to do negative 2, 0, and 1. Notice I left myself some space so I can kind of squeeze my work in there. All right, so I'm substituting in the negative 2 into this guy right here. So I've got negative 2 squared over negative 2 plus 3. All right, what's negative 2 squared? 4 over negative 2 plus 3 is 1. So my answer is 4. All right, plugging in my 0. So 0 squared over 0 plus 3. What's 0 squared? 0 over 3 is going to be 0. Good. Okay. And then I'm going to plug in my 1. So 1 squared over 1 plus 3. What's 1 squared? 1 over 4 would just be 1/4. Again, not hard, tedious. Okay. Yeah, our derivative was kind of a pain because it was quotient rule. Our table was a pain because we had fractions, but it is what it is. It's not hard. Okay. Yeah.
Isn't there supposed to be a plus 6x in there too?
No, because I'm going back to my original. Yeah, you go back to your original when you do the calculation. Okay. You're welcome. I had to think about it too, but it's the original we're looking at. Okay. So what was it said absolute global maximum. So what is the biggest number? 4 in the table. So this is our absolute max. So we just have to write the sentence. And I'm going to go back to the context of the problem always, right? If they use global, use global. If they use absolute, use absolute. Okay. If they just say maximum, just say maximum. The global maximum is for at x equals negative 2. We cover all of our bases that way. Okay. Okay. It's more of the same. It's just we're gonna practice some other derivatives we haven't seen in probably a couple of weeks. So it's the same process, just derivative practice at this point. Okay, it's an easy way to sneak this in there. All right, so we're gonna find the absolute extrema for g of x equals x squared minus 1 squared over 2. I would probably think of this like 1/2 x squared minus 1 squared. Okay, so the first thing that I need to do is to find my critical numbers. How do we find critical numbers? Take the derivative. Perfect. And what rule am I going to need for the derivative this time? We're almost there. It's not quotient or product. It's a chain rule. Look outside, there's an inside function, right? Now, when it's a squared like that, you actually have a choice. If you wanted to FOIL that out and then take the derivative of the FOILed out thing, you can. But then you're doing another algebraic piece, okay? Or you can do the chain rule. It's kind of up to you on that. If it was a cubic, I would definitely do the chain rule, right? Because it's going to take you longer to multiply it all out, and there's more room for error, okay? But on a squared, that's your option, okay? All right, I'm going to put my kind of u off to the side. I'm still doing this long way. So x squared minus 1. So what is u prime equal to? 2x, okay. And let's see, if I was going to look at, I'm just calling it's g, right? So g equals 1/2 u squared, right? So g prime is equal to, where's this 2 going to go? Yep, so I end up with 2 over 2 u times the derivative of the inside, which is 2x. Sorry, that got really tiny. All right, so I'm going to go back to and fill in my original here. So g prime is actually, I probably shouldn't have used g. I should have probably used an f there. Sorry about that. All right, so I'm going to keep this 2x. I'm going to throw it in front, and then I'm going to put my u in. My u is the x squared minus 1. Resist the urge to distribute. Okay, sometimes we're just so methodical. Okay, we see that, we want to distribute it. But think about what the next step is. We're supposed to set that equal to 0, right? Well, if I distributed it, wouldn't I just have to factor it back out? So and then I would use the and then use the zero product property. It's already set up zero product property for us. So let's just do that. I also wouldn't do difference of squares. I would just set that equal to 0, right? Because difference of squares and solving with roots both are equally easy, okay? All right, so 2x equals 0 and x squared minus 1 equals 0. That's a squared. Okay, so x equals what when I divide by 2? Okay, and then x squared equals 1, and then I take the square root of both sides, make sure you put a plus minus, so x equals plus or minus 1. And guess what? I didn't give you an interval, did I? The interval did not get on there. So the interval, we're going to add that on there, okay? On the interval from -3 to 2. Okay. So are all of my values inside that interval? Yes, which means I'm going to have to calculate 5 numbers this time. Okay, so tedious, but totally possible to do. Okay, so I have my x, and I'm going to start with, let's see, my smallest looks like -3. I tend to try to go in order. You do not have to go in order at all. It's not wrong to not go in order. 0, 1, and 2. So we test our critical numbers and our endpoints. And then this was g of x this time. I'll zoom back out so you can see the whole thing. Okay, let's work smart and not hard, okay? So table 1 is going to do -3. Okay, table 2, you're going to do -1. Table 3, you're going to do 0. Table 4, you're going to do 1, and table 6 over here, you guys are going to do 2. Because everybody plug in. All right, practice the plugging in part. Give you about 20 seconds. Okay, check with your table. See if you all got the same number for your row. Okay, let's see how we did. So table 1, what'd you get for yours? What'd you get for -3? Anybody at table 1? Yes. Did anybody do -3? Do you see you all see the numbers on your tables, right? That's your table number. Okay. All right, well, apparently we're doing -3 together. So what is 8 squared? 64 over 2 is 32. Okay, table 2, what'd you get for -1? Good. All right, table 3, what'd you guys get for 0? What'd you guys get? 1/2. Good. Okay, table 4, what'd you guys get for 1? 0. Good. Okay, and then table 6, what'd you guys get for 2? Perfect. Okay. So let's see. It asked us to find absolute extrema, meaning they want both the maximum and the minimum. When you see that, that's the plural. Okay. So you need to do both. So we're going to have to write 2 sentences. Okay. So let's see here. The absolute, we'll go with min first. Min of whatever this function was. I haven't named the function. Other ones you can. We probably should have. Of g of x is, all right, so what number is the smallest? It's 0, isn't it? And guess what? It has 2. Even though it's absolutely only supposed to have 1, it has 2. Is 0 at x equals, now you can write it fancy. It happens at both plus and minus 1. And you are allowed to write plus minus, that's fine. All right, the absolute maximum, I'm being a little bit lazy, I'm not spelling out the word maximum, of g of x is, what's the biggest number that we've got in there? 32 at x equals -3. Okay, how are we doing time-wise? We still have quite a bit, right? Third period, 16, yeah, we got plenty of time. Okay. Again, it's more of the same, except that we're going to practice some derivative stuff we haven't done in a while. Okay. I want to say that most of the ones, because I just did a Delta math assignment, so it doesn't have some of these other complicated ones. It's going to be mostly just polynomial kind of stuff or rational kind of stuff. All right, we got it?